All right, we're going to talk about exponent properties today. These are properties that hopefully you had explained to you and shown in practice in Algebra 1 and then reinforced in geometry, but it may not be the case. So I want to go back over those and make sure that we know those exponent properties and get some practice using them, because we're going to be using them all throughout the year. So first of all, I have a list of all of them with examples, and then I've got the stuff out of the actual Algebra 1 book where we would have learned those, and then there's a bunch of practice pages at the end, and we're going to do a little bit of each practice page so you see how and what I want on that page. So let's start. The first one is the zero exponent. Any number raised to the and I'll do my laser pointer. Any number raised to the zero power is equal to 1, except for 0, which is undefined. Okay, so here we see a to the 0 equals 1, as long as a is not 0, because 0 to the 0 is undefined. It's actually a debate in the mathematical community. It might be 1, it might not be. The way that Sal Khan of Khan Academy likes to explain this is when you have a number to an exponent, right? What that is saying is you are taking 1 times that number that many times. So 2 3 times. So 1 times 2 would be 2, times 2 would be 4, times 2 would be 8. Okay? So if you take 2 to the 0, you're doing 1 times no 2's, which would just be 1. So 4 to the 0 is 1, 2500 to the 0 is 1, a to the 0 is 1, giraffe to the 0 is 1. Anything with an exponent of 0 turns into a 1. Negative exponent. This is one of the toughies to do, mainly because of the way people explain it. Negative exponents indicate a reciprocation, okay? A flip over. That's what a reciprocal is, with the exponent of the reciprocal becoming positive. Okay, so when you make this change, the exponent changes from negative to positive. Basically, the rule is no negs. You can't have them. So if I have a to the negative n, any exponent, that n is a number, that's what it is. What it does is it turns into 1 over a to the n. Well, that's because this is technically a to the n over 1, and then we do a reciprocation. We flip it over. Okay? I like to think of it more like this: a to the negative n, and then there's the divide line. And the negative exponent means it's going to jump the divide line. If it's on the top, it jumps to the bottom. If it's on the bottom, it jumps to the top. So that means a to the n goes down here. Now, what was left over? Well, anything is always times a 1. It's always hanging out in front of there, right? I've got 1a to the negative n. So it just leaves the 1. The 1 didn't have the negative exponent. The a did. So it flips it down. And the reverse is also true. If I've got 1 over a to the negative n, that's going to mean the base, the a, jumps to the top. So I've got 1 times a to the n, and then I've got a 1 left down here. And I don't really need those. I can make them invisible, because 1 times anything is itself, and anything divided by 1 is itself. Okay? So they've got an example here, and at that 3, it's going to jump to the bottom and it turns positive. That 4 is going to jump to the top and it turns positive. That n is going to jump to the top and it turns positive. That's what you do with negative exponents. Here's where it gets very tricky. If I've got 3x to the negative 2, okay, I'm going to draw my divide line. I'm going to drop the x, and it becomes 3 over x to the 2, 3 over x squared. The 3 technically, let me change my color here, has a 1. And that 1's positive. So the 3 doesn't move. The x is the only one that has the negative exponent. Okay? That's how negative exponents work. Whatever's in there flips it over. Now, the other one that I do want to show you is like if you had a 1/2 to the negative 2. There's more properties we're going to look at later, but that basically flips both. The 2 goes and the 1 goes. The whole thing flips over and it becomes 2 over 1 squared, or just 2 squared. Okay? Product of like bases. If the base is the same, then you add the exponents. So that becomes 3 plus 2, which makes the 5. Okay? And 2 to the 5th is 32. That's how the product goes. Okay, so when product means multiply. Okay, product means multiply. Quotient. Quotient means divide. Okay, also ratio. Same thing. Okay, piece on top, piece on bottom. For those of you that don't know, the divide symbol, right, if I make a divide symbol, these are actually blanks that you fill in, right? So this could be 1 over 2, where this was in a box and that was in a box. It's the divide symbol. That's what it means. This divided by that, this over that. Okay? If things are in division, same base, then I can subtract their exponents. Okay? So 3 to the 5th over 3 to the 3rd becomes 3 to the 5 minus 3, or 3 squared, which would be 9. Here's how I like to do that. Okay? 3 to the 5th over 3 to the 3rd. Which one's bigger? The 5 is. Subtract them. The 3 is going to be on top. 5 minus 3 is 2, which makes 9. If it was 3 to the 3rd over 3 to the 5th, technically that's 3 to the 3 minus 5, which is 3 to the negative 2. It's going to move, which becomes 1 over 3 squared, which becomes 1/9. So the way I like to do it is when I have same bases dividing, I circle where the biggest number is. That's where that base goes. The 3 is going to end up in the bottom because the 5's bigger. Now I just do 5 minus 3, which is 2. And I've got 1/9. Okay. Power to a power. Raise a power to a power. Keep a base and multiply the exponents. If you have a power to a power, turns into a multiply. So 2 squared to the 3rd, multiply them together, change your x to a dot. We don't use x as a multiply anymore. Dot is a multiply. X is a variable. Do not use x's for multiply. 2 to the 6th, which would be 64 eventually. Okay. Product to a power. If two things are multiplying inside, they're next to each other, so they're multiplying, there's a dot there, and they have an exponent, it gets distributed to both bases. So 2 times 3 on the inside, it's 2 squared times 3 squared. The squared goes to both. You can also reverse that. If you have 2 squared times 3 squared, you can turn that into both of them being squared and make it 2 times 3, which would be 6 squared. Okay. Order of operations, I would have turned this into 6 and left it squared, not turned it into 2 squared, 3 squared. So it's more like if it's A, B squared. Both A and B get that. A squared, B squared. If it was already A squared, B squared, and then it was to the 3rd, it becomes a multiply. 2 times 3 becomes A to the 6th. 2 times 3 becomes B to the 6th. And then we could also reverse it and turn it into AB to the 6th. It would work that way as well. Quotient. Remember, product is multiply. Quotient is divide. To raise a quotient to a power, raise the numerator and the denominator. It's just a distribute again. Technically, there's a 1 here, so it becomes n times 1 and n times 1. So a to the n over b to the n. You can also reverse it. If you have a to the n over b to the n, if they have the same exponent, pull that exponent out, and it becomes a over b. This is why that 1/2 to the negative 2, technically I give it to both, and it becomes 1 to the negative 2 over 2 to the negative 2. Now the 2 moves and the 1 moves. So it becomes 2 squared over 1 squared, or 4 over 1. Okay, we've got that here. Distributes to both. So we get 4 over 9. Okay, that's quotient. And then lastly, the rational exponent. Just like divide and multiply are buddies, and add and subtract are buddies, right? 5 minus 2 is the same thing as 5 plus negative 2, right? And 4 divided by 2 is the same thing as 4 times 1/2. Like the divide symbol is the line, right? They're the same thing. Well, exponents and radicals are opposites, just like that. So the top is the exponent. The bottom is the index of the radical, okay? You need to change your little paper here so that the y is inside the little hook of the radical. For some reason, it they typed it very crappily, and I don't know why. But it's inside the hook, okay? So in here, this zone is your index. It's what root you're doing, okay? That's the bottom number. So the 3 goes here, the 2 goes there. Just like that, okay? And you can switch back and forth. If it looks like a radical, you can turn it into an exponent with a fraction. If it looks like an exponent with a fraction, you can turn it into a radical. Flipping back and forth. That's what equals does. Goes both ways. All right, so here's what you should have learned in Algebra 1. This was Chapter 6. You may not have gotten to it because that happens later in the year, and sometimes we don't get as far as we need to. So we want to make sure we know these rules. And it's just the same ones we did. There's the 0. Anything to the 0, 1. Negative exponents, 4, drops to the other side. Negative exponents, A, drops to the other side, goes to the bottom. Okay, they've got some example problems here. You can read over those and look at them. Anything to the 0 is 1. This is going to be, drops to the bottom, so it becomes 1 over negative 2 to the 4. Notice the 2 didn't change sign, but the 4 did. When you move it, the exponent changes. Okay, the exponent changes. Now, it's in parentheses. That's important because that means it's negative 2 times itself 4 times. Negative times negative would be positive, times negative goes back to negative, times negative goes back to positive. So that would be 1 over positive 16. Okay, this one's fun. X to the 0 turns into a 1, so I'm just going to cross it off. And now the y needs to jump up, and so it becomes 4y to the 3rd. All right, so here are some monitoring progress. Pause it right here, write these ones down, give it a try, and then come back and play the video and see how you did. Okay, number 1. That's a 0 exponent. Anything to the 0 is 1. That's got to jump. It's a negative exponent, so it becomes 3 on the bottom to the 3rd, which is 1 over 27. Not sure how far they took it or if they left it as to the 3rd. Anything to the 3rd, you should be able to still write. Anything above that, I'm fine if you leave it looking like the exponent unless they want you to keep going. Then get the calculator out, do 3 to the 5th, and see what it is. Okay? This turns into a 1 because anything to the 0 is 1. The 2 needs to come up, so it becomes 2 squared, which is 4. Oh, forgot to circle my answer. There we go. Simplify the expression. Don't need the y anymore because anything to the 0 is 1. The 3 is going to drop down. The x is going to drop down. So it becomes 1 over 3 squared x to the 5th, which is 1 over 9x to the 5th. Okay, so using only positive exponents, bam, we changed them. Okay. Product property. Using the properties of exponents. The power one, whenever you're multiplying things with the same base, you add the exponents. When you're dividing things with the same base, you subtract the exponents. 6 is bigger, so the 4 is going to stay up in the top of the fraction. Okay. And the power of a power. Power to a power we multiply together. So here's an example. 3 squared times 3 to the 6. Well, it becomes an add, which is the 8th, which is that. I'd be fine if you stopped right there. If the book gives you the answer to the end, check it, see if it's right. Okay. This one, they're in division. The 7 is bigger. So I know that the negative 4 is going to end up in the bottom. 7 minus 2 is to the 5th. And I'd leave it right there. They did 1024. It's not that big of a number. Type it in the calculator, figure out what's going on. The parentheses are important. Type that when you type in the calculator. Let's look at the difference. Okay. 1 divided by negative 4 to the, 5th, versus 1 divided by parenthesis, negative 4, no, that's a 5, to the 5th. Look at the difference. Okay, well, it's to the 5th, so it doesn't matter that much. But let's say it was to the 4th. Let's look at what to the 4th would do. If I can get in my answer, even the bottom. Okay. Notice the difference in the to the 4th. When it's an even exponent, it matters where those parentheses are, because if you don't put the parenthesis, it gives you a negative answer. If you do put the parenthesis, it gives you a positive answer. And the positive's correct in this situation. It's order of operations, PEMDAS, parentheses, exponent, multiply, divide, add, subtract. 4 to the 4th happens before negative 1 times 4 to the 4th. That's what your calculator's doing. So be careful. Okay? Z, that goes multiply, which makes it z to the negative 12. not 7. Don't add them, multiply them. And then z has to jump, so it becomes 1 over z to the 12th. Okay, that's a jump arrow. Sorry about that. Here's a couple of examples. Give it a pause right here, and let's see what you do. Okay, here we go. Same base. They're going to add together. 4 plus negative 6 makes 10 to the negative 2, which means it's going to jump, which is 1 over 10 squared, which is 1 over 100. X to the 9th and x to the 9th, add them together, gives you x to the 0, which is 1. 8's bigger, so we're going to subtract them, so that's negative 5 to the 4th. And I'm just going to circle it, but for kicks and giggles, let's see. Negative 5 to the 4th, 625. A good rule of thumb also is any number to an even exponent is going to end up positive. So that's just 625. The 7 is bigger, so it's going to be 1 over. The y is going to end up on the bottom. 7 minus 6 is 1. We're going to multiply those. Negative times negative makes positive. 2 times 1 is 2, which is 36. We're going to multiply those, which is w to the 60th. Okay. Power of a product. Okay, remember that's going to distribute. You got like a 1 here and a 1 there. 5 times 1 is 5. 5 times 1 is 5. Really, I would have done this and said 6 to the 5th. But that's what they tell you. It's easier with, it's more going to happen with letters. Okay, because you're going to have to distribute it out to simplify. So more pay attention to the letters. Like here, the 3 and the 2 can't divide, so I'm going to give it to both. 3 to the 5th and 2 to the 5th, and whatever those numbers are. Okay. More examples. They've got them worked out for you here. Notice that there is another way to solve this problem. They do it in 2 different ways for you. You're welcome to look that over. Give it a pause. Look it over. See if you agree with what's going on there. Now pause it and try these. Okay. It goes to both. So that's 10 to the negative 3. And then y to the negative 3. And they're both negative, so they're both going to hop the line. So that becomes 1 over 10 to the 3rd, y to the 3rd. Which is, I'm going to go back this way, 1 over 1,000 y to the 3rd. Okay. And instead of distributing, you could have also just... Let me do a different way here. Could have also just said, well, that whole thing has to jump, so now it's 1 over 10y to the 3rd, then distribute, and you get that 1 over 10 to the 3rd, y to the 3rd, which is 1 over 1,000 y to the 3rd. Okay. It's going to go to both. I'm going to give the negative up there. Doesn't really matter. So negative 4 to the 5th over n. Technically, that's a 1 in front of there, so I could even leave it off of there, and it'd be negative 1 to the 5th, which is negative 1, times 4 to the 5th, which is whatever that is, and they go higher. So what was that? 4 to the 5th, 4 to the 5th is 1024. If it's a negative number to an odd exponent, it is how it started. So it's going to be negative 1024 over, don't forget the 5th, into the 5th. Everybody gets it. To the top and to the bottom, everybody. So that becomes 1 to the 5th over 2 to the 5th, k to the 10th. Because everybody gets it, the 2 and the k. They're not the same base, so they both get a distribution there. Okay, the 6 gets it, the c gets it, the 7 gets it. But before that, I'm going to, well, I'll distribute it, and then I'll show you the other way. So 6 to the negative 2, c to the negative 2, 7 to the negative 2. It's going to go up, it's going to go down, it's going to go down. They're going to flip sides. So it becomes 7 squared over 6 squared c squared, or 49 over 36c squared. You could also, when it's a fraction and a negative, flip the fraction, make it positive. So it becomes 7 over 6c squared, and then we distribute 7 squared, 6 squared, c squared, and it still gets us 49 over 36c squared. Okay? That's how they go. Let's look at each page. I'll do 3. This is your halfway point, probably, of your notes. So if I said watch half, stop there, and then tomorrow do these. Okay. So negative 2 squared, you could do your calculator, but practice your things. What's 2 times squared means it times itself. So what's negative 2 times negative 2? Well, negative makes positive. 2 times 2 is 4, so 4. Negative 6 to the third is negative 6 times negative 6 times negative 6. Neg, neg, neg makes neg. 6 makes, who's to say? 36 times 6. 36 times 6. 36, 6, 30 is 18, 19, 20, 21. So 216. Okay. And I'll do one from the other column. Negative 3 to the third is going to be negative. Odds start and finish the same. Evens always positive. And then 3 to the third is 27. And how do I know? Because I've done it a lot and memorized it. Okay. These get a little trickier. Look, it's a negative exponent. It's going to jump. So it becomes 1 over 3 to the third, or 1 over 27. If it's to the third or less, finish it. If it's more than to the third, just leave it as an exponent. Okay. 9 squared would just be 81. Don't have to jump it. This one jumps. So it becomes 1 over negative 3 to the fifth. And I'm just going to leave it because it's bigger than to the third. If you did do it, I don't know, what's negative 3 to the fifth? Negative 243 if you actually did it. And I know it needs to be negative because it's odd. If it was even, it has to be positive. Watch out for that. Now we put letters in the mix, okay? The numbers go together, so 8 times 9 makes 72, and h and h, I've got 1h and I've got negative 2h. Well, that makes h to the negative 1. Well, that means h is going to jump, so that's 72 over h. 5 times 4 is 20. C and C, 2 minus 4 is the negative 2. H doesn't have anybody else, so it just hangs out. We got to drop the C. 20. H to the third over C squared. And let's look at this one. 1/3, 1/3, 1/3. So that means I add the exponents, the base, the fraction, that's the base. That's just like a to the fourth times a squared times a to the third. They're all a's. They're all 1/3. So that becomes 1/3. 4 plus 2 is 6, plus 3 makes 9th. Just like that. Should contain only positive, so 5 is bigger. So it's going to stay in the top. 5 minus 2 is 3. What's 7 to the third? Let's find out. 7 to the third. 343. Whee! Okay. R over R to the 6. That's a 1. When you don't see it, it's a 1. So it's going to end up in the bottom. 6 minus 1 is 5. 3 divided by 4. They don't. So it just stays 3 and 4. Why? This one's going to come up. I've already got 1. 2's coming up. So it's going to be y to the third. Just like that. Do it a piece at a time. Do the numbers. Do this letter. Do that letter. Do that letter. One at a time. This is going to be a mix of stuff. 9 times 5 is 45. I got a B and a B. There's 1B and 3B. That's B to the fourth. I got W and W. 5 plus 4 is W to the ninth. This H is coming up, adding to that one. I've already got 1 on top. The C is coming up. It's adding to that one. So I got H to the 5 plus 1 is 6. C to the 4 plus 1 is 5. Nothing happens to the 5. It doesn't have any exponents. It can't divide. Voila. Same base. Add them. A negative 3 plus a 6 is just 3. And we already did that one. 343. Powers of products. Simplify the exponents. 3z squared times z squared to the third. Well, I'm going to do the inside first. PEMDAS, right? Parentheses first. So I'm going to make that 3z, 2 plus 2 makes 4 to the third. Now the 3 goes to the 3 and to the 4. So that's 3 to the third, z to the 12th. They multiply. And then 3 to the third is 81, z to the 12th. C. One of them, two of them, and two of them makes 2c to the fifth. All of that to the third. It goes to the 2, it goes to the c. So that's 2 to the third, c to the 15th. They multiply. So that becomes, 2 times 2 is 4, times 2 is 8, c to the 15th. All the way simplified. N, and n. And 4 times 3 makes 12. N squared, and n squared is into the fourth, and into the first makes into the fifth. All to the third. 12 to the third. into the 5th to the 3rd. So whatever 12 to the 3rd is, we're just going to leave it as that because it's, well, no, we can do 12 to the 3rd. Let's do 12. 12 to the 3rd is 1728. So that's going to be 1728. 5 times 3 is into the 15th. And voila. Powers of quotients. Simplify first. 5 minus 1 makes 7 to the 4th. Squared makes 7 to the 8th. You can leave it there. 5's bigger, so that becomes g. 5 minus 4 is 1 to the 3rd, so that's just g to the 3rd. The 2's bigger. 1 over w all to the 3rd. Well, that's 1 gets it, w gets it. 1 to the 3rd, w to the 3rd, which is 1 over w to the 3rd, because 1 times 1 times 1 is 1. And the last one, well, no, it's not the last one, but 3 times 2 is 6. H and h, they both have 3. They add, which makes h to the 6th squared. 2 squared and h to the 6th squared. Or sorry, 6 squared and h to the 6th squared. So 6 squared, h to the 12th. That's 36, h to the 12th. 4 to the 5th, h to the 5th. Y to the 4 times 5. So 4 to the 5th, h to the 5th, y to the 20th. And you can leave 4 to the 5th is to the 5th. It's bigger than to the 3rd. The 2's bigger. 2 minus 1, just an 8. 8 to the 1st. To the 3rd. Whatever 8 to the 3rd is. Let's see. 8 to the 3rd. 512. Operations with exponents. 5 to the 3rd minus 5 to the 1st is going to be 5 on top. 3 is bigger. 3 minus 1 is 2 squared, so that's 5 to the 4th. On the y's, let's see. Does anything happen to the 5? No, the 5 stays on the bottom. Leave the 3rd outside. The 3 is bigger. Y stays on the bottom, it becomes squared. The 4 is bigger. S stays on the bottom, it becomes to the 3rd. That leaves me with a 1 up top. The 3 goes to everybody. So that becomes 1 to the 3rd, 5 to the 3rd, y to the 6th, s to the 9th, which is 1 over, double check, 5 to the 3rd should be 125, 125, y6, s9. 4 divided by 9 doesn't, so it just stays 4 and 9. This is going to move. There's already 1 down here, so it becomes g to the 5th. Okay, and I believe, yep, we're on the last page. The last page is just function version. H of n, that's h of n. That's what that means. N is just a variable for any number. Sometimes you would see it as h of x. And then they tell you n is this. So you're just going to take this negative 3 and you're going to put it right there and right there. This side does nothing. That's just telling you what number am I plugging in for n. I'm going to plug in a negative 3. So it becomes 7 times 6 over 5 to the negative 3. And what I'm going to do is I'm going to do 7 times parenthesis 6 divided by 5 parenthesis, nope, back outside parenthesis to the negative 3. And it says round to the 100th. That's 2 decimal places. So 4.05 behind the 5 is a 0. It stays there. So it's about 4.05. Okay. This one just means I'm going to plug in a negative 2. So 1/2 times 2/3 to the negative 2. So 1 divided by 2 times parenthesis 2 divided by 3 close parenthesis to the negative 2. And the 2 has a 5 behind it. 5 and above, give it a shove. So that becomes approximately, that's why we do the wiggly equals, 1.13. Okay. This becomes 3 over 7 times 1/2 to the 2. So delete that one, and we've got 3 divided by 7 times parenthesis 1 divided by 2 over parenthesis to the squared. And we've got approximately 0.1. Behind the 0 is a 7. That's 5 and above. Give it a shove, so that's going to become a 1. And it works just like that. Okay? So, get to work. Finish the packets. Turn them in.